Thank you. So I'm going to be breaking the trend. I'm not going to be talking about physical visualizations. Instead, I'm going to be talking about something that I think is very important, and that is individual differences matter. Our background, culture, and experiences all affect the way we think, perceive, and solve problems. So why should visualizations all be the same for all users? In fact, this isn't a novel concept. Researchers in the visualization community has shown that individual differences such as spatial ability, experience, emotional state, and personality all affect the way we use visualizations. However, even though this prior research has shown that individual differences affect our performance in visualizations, very little is known about how or why individual differences affect performance. Do user groups adapt different problem-solving strategies? How do we choose between existing visualizations? And furthermore, how do we design new tools to facilitate users' needs? To address these questions, we focus on the personality locus of control. Now, locus of control describes the extent to which someone feels in control of external events, and there are two extremes to this construct, where there's internal locus of control, and these people believe that they can influence external events, and people with external locus of control believe that they are influenced by external events. Researchers in the visualization community has shown that locus of control can influence your performance, specifically your speed and accuracy, on different visualization tasks and visualization forms. However, we hypothesized that the differences observed in the prior results, the differences in speed and accuracy, are actually due to differences in user strategies. To investigate this, we designed an experiment where we looked at people's interactions as they used two different hierarchical visualizations. These hierarchical visualizations were chosen because they're commonly used in real-world scenarios to represent hierarchical data. We recruited 54 participants and tested locus of control using a standard psychological survey. The data set used in our experiment was a biological taxonomy. It was fairly unknown to our participants, and each participant performed simple search tasks using the two visualizations. So an example of a search task would be, under a specific classification, find a species with a specific attribute. And while they interacted with the visualization to search for the target, we captured their mouse click and their mouse hover interactions. Consistent with prior work, we found that locus of control impacted interaction times. To look at this, we separated users into two groups based on their locus of control scores, externals and internals, a median split, of the locus of control scores. On this graph, we show on the x-axis are the two visualizations, and the y-axis is mean interaction time. Externals are in blue and internals are in green. What's important about this graph is that we found that no visualization was good for both users. Specifically, we found that externals were better with the indented tree visualization, whereas internals were better, faster, specifically with the dendrogram. But are these differences in interaction time due to differences in strategies? And to look at user strategies, we graphed users' interactions. And the node in this graph shows every data point in the data set. The links represent subsequent clicks, and the weight of each link represents the percentage of users from that specific group who would have traversed that link. By looking at these graphs, we were able to find that the strategies of users differed not only within groups, but also across visualizations. Specifically, we found that when externals were using the dendrogram, their search patterns were somewhat random. It was very difficult to find patterns in their searches. Whereas when internals were using the exact same visualization, doing the exact same task, they tended to use a combined depth first, breadth first strategy. When externals, on the other hand, were given the indented tree, they tended to use a strictly depth first search strategy. And if you notice, the right side of this tree is completely untouched by the externals. Internals, on the other hand, when they were given the indented tree visualization, they tended to do, again, a combined depth first and breadth first strategy, which actually proved to be not very successful because they were really slow with this strategy using the indented tree. Overall, our results we found that internals, prefer control and tend to struggle when an interface doesn't fit their mental model. On the other hand, externals preferred an interface that had an implied search strategy, and when an interface didn't have an implied search strategy, when it was too flexible, they got lost in the visualization, and they tend to struggle with that one as well. In conclusion, with our results, we now have answers to why locus of control affect performance. Specifically, we realized that the observed differences in speed and accuracy are actually due to differences in user strategy. And now we actually have an understanding of how locus of control can impact someone's strategies using visualizations. And that's it. Thank you.
Hi there, Helena Mentis, University of Maryland, Baltimore County. So I don't know a lot about the locus of control theory. So I'm thinking about patients and their feeling of locus of control when they've been diagnosed with a big disease, and whether or not that actually can influence, if there's somebody who had an external and then would maybe become an internal because of that. Do you think that happens with this type of, concept, and would that impact the way that they would want to then look at their health data as they're trying to work through their health trajectory?
That's an interesting question. Thanks for your question. I do know that locus of control can impact health, not in terms of understanding, but prior research has shown that people with internal locus of control, they recover better from diseases, whereas people with external locus of control may struggle or may give in to their disease or give in to their condition. I've also looked at how locus of control can affect the way people perceive complex statistical information, specifically Bayesian reasoning problem as it relates to healthcare information. And unfortunately, I did not find anything with locus of control, but spatial ability does affect people's, ability to perceive this type of information.
Okay, great, wonderful. Thank you so much.
Thanks.
So here you said, we now have answer to why and how LOC have this impact. So could you guess how this LOC would impact another tree visualization, like tree map?
So there's a reason why I actually did not choose a tree map. I considered using a tree map for this experiment, but the way people would interact with a tree map, usually you don't, when you interact with the tree map, you see the entire tree map all at once, and you would click to either zoom in or click to filter. And that interaction is very different from when you click to expand to see more. So I have no idea how it would react, but it would be interesting to look at different tree visualizations and that way of interaction and see how that would impact it.